In today's video, I want to talk about React, which is reasoning and acting. It is a framework that enhances large language models by integrating both reasoning and action capabilities. So, the traditional LLM is primarily just focused on the generating language output and based on its input prompt, right? However, they often lack the ability to interact with the external environment or perform some specific actions that require reasoning, which is beyond the text generation. But React addresses this limitation by extending the action space of the large language models to include both task-specific discrete action and natural language reasoning. So this integration allows the LLM to think through the problems and interact with the external system or environment to achieve its goals. If we want to understand React, we have to delve into two very detailed examples to understand how React works in practical. So the first one is knowledge-intensive task, which is HotpotQA, and another is decision-making task, which is LLM environment. First, let's talk about knowledge-intensive task, which is HotpotQA. So HotpotQA is a question-answering dataset that requires multi-hop reasoning over multiple documents or pieces of information to arrive at the correct answer. The example is the question, what device is originally designed to interact with the front row media center program, and what other device can control it? So the React in action in this large language model use the combination of thought, which is reasoning, and actions, which is search queries, to find the correct answer. Now let's try to break it down step by step. Thought 1 is I need to search for Apple Remote to find the program it was originally designed to interact with. So the action 1 is it search Apple Remote, and the observation 1 is this Apple Remote is remote control that's introduced in October 2005 by Apple. It was originally designed to control the front row media center program on Mac computer. And thought 2 is this Apple remote was originally designed for front row. So I should now search for front row to see what other devices are controlled. So now we have action 2, which is search for front row. And we get the observation 2, which is could not find the front row. But we have similar result, which is include front row seat to earth, or front row motorsport, or front row software. And then it has thought 3, which is front row alone didn't yield any design information. So I should search for front row software. And action 3 is we search for front row software. And observation 3 is front row is a discontinued media center software application for Mac OS X. It can be controlled by the Apple remote or the keyboard function keys. And then the thought 4 is now I know that front row is software that can be controlled by the Apple remote and the keyboard function keys. Therefore, the other device that can control it is the keyboard function key. And action 4 is now we know that keyboard function key is our final answer. In this example, the LLM demonstrates iterative reasoning, which is at each step, the LLM thinking about what information is needed next, and then action execution. It performs search action based on its thoughts, and then its observation, processing. It read and understand search result to inform the next thought. And the last one is conclusion drawing. Finally, it uses the accumulated information to arrive at the correct answer.